Welcome to another class. In today's class, we are going to continue from our previous lesson. Remember that previously we had discussed something concerning how we can use the Gibbs-free energy as a thermodynamic parameter to explain spontaneity of a reaction. So we're going to take a few examples to see how we can apply that. So today we are going to look at calculating, or you can say determining, calculating Gibbs free energy. Calculating the Gibbs free energy. We're going to go straight to the point. Remember that we had mentioned earlier that the Gibbs free energy is defined as delta G is equals to delta H minus T delta S, where of course we know that this is the Gibbs energy, this is the enthalpy, and this is the entropy. We have mentioned that while this of course is the temperature. We had discussed this already sometime in our previous earlier classes. Now we are going to see how we can apply this formula to solving Gibbs free energy and use that solution to determine whether the reaction is actually spontaneous or not. Now, supposing we are given a reaction, let's use water solid to water liquid. Let's say we are given a reaction where the water in the ice form, okay, is being melted into the liquid form. Rather, water is the solid, liquid, and gas. So it is more like it has ice, it has a liquid form, and also have the water vapor form. So we have a reaction that involves melting of ice to the liquid form of water. And in this reaction, we are told that delta H, which is the enthalpy, is 6.0 kilojoule per mole, and then we are told that delta S, which is the entropy, is 22.0 kilojoule per mole per Kelvin. Okay, and then the temperature of operation is 20 degrees Celsius. Okay, let's say we are given this. Okay, this reaction has a heat of 6 kilojoule per mole, has an entropy of 22.0 kilojoule per mole per Kelvin, and a temperature of 20 degrees Celsius. Now, it's important for us to see how we can be able to calculate Gibbs free energy using this equation. So we're going to fit these values into this equation. Now let's see how we are going to go about that. Now we'll start our solution here. Now it means that our delta G will be equals to delta H. Delta H is given as 6.0, so it's given as 6.0 kilojoule per mole, okay, minus the temperature is given as 20 degrees Celsius plus 273 degrees Kelvin. Remember that we are going to convert from the Celsius to the Kelvin. So this will give us Kelvin, and then we multiply by what? We multiply by the entropy. The entropy is going to be 22.0 kilojoule per mole per Kelvin by 1000, because we have to start converting it in order, because of the presence of the Kelvin, we have to convert this very value. Now, this Kelvin, of course, will cancel this Kelvin out. Therefore, we are going to have a solution from that. So from here we'll have that delta G is equals to 6.0 kilojoule per mole, okay, minus what? 293 Kelvin, because this is okay, later remove the Kelvin from there since it cancels out. So 293, 20 plus this will give us 293 Kelvin. Then we are multiplying this by this. 22 divided by 1000 will give you, should give you 0.022 kilojoule per mole. Okay. Alright, at this point here, we'll have 6.0. There's kilojoule and there's kilojoule, so you have to just take one of it. So 6.0 minus, if we multiply 293 by 0.022, we should have something closer to 6.44 or so, and this is in kilojoule per mole. Okay, so it means that our delta G will be what? 6 minus 6.44 will give us minus 0.44 kilojoule per mole. This is what we will have calculated out as our what? As our gas-free energy. Now, arriving here as our gas-free energy, what does this tell us concerning that reaction where water is converted or melted to the ice form? What does this answer tells us? Now remember that, now note that our delta H was plus 6.0 kilojoule per mole. And also note that our delta S was plus 22.0 kilojoule per mole. And now our delta G is minus 0.44 kilojoule per mole. Did you see that? Now it simply means that an endothermic reaction that leads to what? Increase in entropy of the system will always do what? Will always be what? Spontaneous. Will always be spontaneous at what? At what? At high temperatures. At what? At high temperatures. That means that for water in a solid form like ice to get converted in that reaction, which is an endothermic reaction, to what? To liquid water, for it to be spontaneous, it means that it must be carried out at what? A higher temperature. I'm sure we have been able to understand how we can calculate and use the solution of the Gibbs-free energy to interpret spontaneity of a reaction. You can link this to our earlier class. I'm glad we had all the time to treat this. Do not forget to like, to share, to also subscribe at my YouTube channel. Do not forget to make your comments very known. Questions you want to ask, do so. It will be all attended to at the comment section of the YouTube channel. Do not forget also to share. Until next time, it is bye for now.